It's always like a ton of it because it's completely empty. So after each class, I upload it to my computer, then I empty it out. So I don't know why it says that. Okay, so the derivative of cosine of x is negative sine of x. So that means your f prime of x, which is, this is your u, so u prime over u would just be negative sine of x over cosine of x, which is negative tangent x. Sometimes you have to dig back into those old derivative formulas. Okay, so we know our arc length is equal to the integral from a to b, the square root of 1 plus f prime of x squared dx. Okay, so it's going to equal the integral, remember it's from 0 to the power over 4, and the square root of 1 plus, you have negative tangent x squared. If you have negative and negative, it's going to be positive. So you have negative tangent of x squared dx. Okay. That becomes from 0 to 4, move that up a little bit. 1 plus tangent squared, well, tangent of x squared.
0 to pi over 4.
Oh, pi over 4, thank you. Okay. Dx. Alright, so from here, just have to go back and remember that 1 plus tangent squared of x is equal to secant squared of x. Trigonometry comes back to haunt you. Okay, so you have the integral from 0 to pi over 4 of the square root of secant squared of x, or secant x squared, however way you want to write it. Doesn't matter, because the square and the square root will cancel each other out. So you end up with the integral from 0 to pi over 4 of secant x dx. Okay. Now the integral of secant is natural log of secant plus tangent. Uh-oh, don't need that one. And that's from 0 to pi over 4. Okay, so if we plug in our pi over 4, you have the natural log secant pi over 4, which is square root of 2, plus tangent pi over 4, which is 1, minus the natural log. If you plug in secant of 0, that's equal to 1, minus tangent of 0, which is 0. So natural log of 1 is just 0, so that disappears. So you have the natural log of square root of 2 plus 1, which actually becomes, well, approximately, since it's not an exact value, 0.8814. Give or take a decimal here or there. All right, so any questions on that one? Bring that up a little bit. So we're going to use that formula to find the area of the surface of revolution. Okay, so just like everything else we've done up to this point, we're going to somehow revolve this around the x or the y axis. Okay, so let's say from A to B, you know that the arc length from A to B, we'll just use s equals the integral from A to B, square root of 1 plus f prime of x squared with respect to x. Okay, so what we're going to do is we're going to get that shape, and we're just going to revolve it around the x-axis. Okay, so let's say this is your x-axis here, or your axis of revolution may not be the x-axis. So you have this original shape, and it kind of revolves around the x-axis. So it kind of looks like that. It wasn't half bad. Okay, so from there, we just really measure. So really what we're doing, we're getting that length, and we're multiplying it by the function, and multiplying it by 2 pi, since we're just revolving it around the x-axis. Okay, and we get the entire surface. You can measure the actual length of the entire surface of that three-dimensional shape. Okay. So the definition of the area of the surface of revolution, let's say if we let y equals f of x have a continuous derivative on the interval AB. Okay, so the area, and we'll use uppercase S, of the surface of revolution formed by revolving the graph of that function about a horizontal or vertical axis. Uh-oh. So you have your uppercase equals 2 pi, and we're going to integral from a to b, f of x times the square root of 1 plus f prime of x squared with respect to x. Okay. So it's really just an extra tweak on the arc length formula. Okay. Now, of course, you can have the same formula if you're going to revolve it around the y-axis. So if x equals some function g of y, on the interval from C to D, the surface area is equal to 2 pi from C to D times some, should have made that G of Y. G of Y times square root of 1 plus G of Y squared with respect to Y.
G prime of 4.
Oh, G prime, thank you. Right. Okay, so let's say for example, if you want to find the area of the surface formed by revolving the graph of f of x equals x cubed on the interval from 0 to 1 about the x-axis. Okay, so just so you can kind of visualize it, you have your x and you have your y. So we know the graph of x to the third kind of looks like that, but from 0 to 1, it looks more like that. Okay, which means it's going to revolve around the x-axis. So it's going to end up looking kind of like a horn, give or take. Okay, so if we're going to find the area of that surface of revolution, so it's 2 pi times the integral from a to b f of x times the square root of 1 plus f prime of x squared with respect to x. So we're going to need our f of x and our f prime of x, just like before. So you know the f of x is equal to x to the third. And f prime of x equals 3x squared. Okay. So now we just plug everything in. So it's equal to 2 pi, and the integral is from 0 to 1. F of x, which is x to the third, times the square root of 1 plus f prime of x squared. I'll just do that on the side instead of rewriting the whole thing. So 3x squared is just 9x to the fourth. dx. Okay. Now this, once again, is where we're going to use our u substitution. So if we let u equals 1 plus 9x to the fourth, and our du, derivative of that is 36x to the third, with respect to x, then that means here, if we kind of rewrite it a little bit, integral from 0 to 1, if that's our u, that would just become u to the 1/2 power. And if we have x to the third, we need 36x to the third to make that du. So we just multiply and divide. So we divide by 36. And we multiply by 36. So now we have 36x to the third dx, which is now our du. So you have the integral of u to the 1/2 du. Oh, sorry about that. Okay, so that's equal to 2 over 36 is pi over 18. Oh, 18, yeah. From 0 to 1, so u to the 1/2 is u to the 3 over 2. So instead of 3 over 2, u to the 3 over 2, so that would be 1 plus 9x to the fourth to the 3 over 2. Over 3 over 2. Oh, don't know why I did that. From 0 to 1. Oops. There we go. Clean enough. Okay, and the 3 over 2, that can become 2/3. Okay, so the 2 and the 18 makes that 3 over 9, which will become pi over 27. Okay, so now if we have that 1 plus 9x to the fourth to the 3 over 2 from 0 to 1. Okay, so now we plug in our 1. We end up with pi over 27. Oh, move that up some. Plug in our 1. We have 9 times 1, which is 9 plus 1 is 10. So we have 10 to the 3 over 2. Minus, plug in our 0. We just get 1 to the 3 over 2, which is just 1. Okay. And plug that into your calculator. You end up with some 3.563, give or take. All right. So any questions on that one? All right. Make sure everyone's done writing. Okay. Were you still writing? Mm-hmm. All right. Okay, so let's say, for example, I want to consider the curve f of x equals 2x plus 1 over the interval from 0 to 6. Okay, so what is the surface area? Generated by revolving the graph of f of x about the x-axis. Oh. Okay, so let's say you want to give the exact answer in terms of pi. So you don't have to give a decimal answer. All right, I'll give you a few minutes to start on this one. Did everyone sign in? Who has the sheet? Oh. No. Anyone beat it? Yeah, pretty much.
So, this is the radius.
Yeah, what we're doing here is where as it's changing this kind of
The 2 pi.
yeah,
Okay.
it's a variation.
That
But
helps.
instead of the